In this video, I'm going to use R and RStudio to look at the data associated with a numeric vector of data. I'm going to create a histogram on that data, and then I'm going to overlay it with the normal probability distribution function for the data in that histogram. We're going to look at doing this two ways. First, we're going to start with some data that gets entered by hand. We're going to take just 8 values, 1, 5, 7, 4, 8, 12, 5, and 6, and put them into a numeric vector. And here I'm going Control Enter to execute one line at a time in RStudio, or I could click on the Run command up here. And I can see my 8 variables. If I generate a histogram, notice down here we have the frequency of the variables, where the greatest frequency is between 4 and 6, where there are 3 variables. The binning of the data, 0 to 2, 2 to 4, 4 to 6, happens automatically for us. We can also give the histogram an optional argument, prob equals true, and instead of returning the frequency, now we return the probability density of each bin of variables. And in probability theory, the total area under the curve needs to equal 1, and that drives the values for the density on the y-axis. Next, we use the curve function to overlay a normal probability distribution curve on top of this data using the mean and the standard deviation from the data. In the program notes to this video, I have some additional references and information on both the curve function and the denorm function. The second case I want to look at is, instead of hand feeding it a small number of numbers, we're going to read them in from a CSV file. And the first step would be to open your browser and download this file from my Dropbox into your browser, into your download folder on your PC or your Mac. You'll need to change the URL to reference your folder instead of mine. Then we'll use the read CSV function to load the data from that file into a data frame called NYC weather. And we can see this is a data frame by running the R class function on it. We can run the dim function, which is the dimension of the data frame, and we see that it's a rectangle of data, like all data frames, like an Excel spreadsheet or a SQL result set, with almost 9,000 rows and 15 columns of data. We can look at the first few columns here, the first 6 columns, and we see that we have the origin, which is the airport where the weather observations were taken, date information, temperature, wind direction, wind speed, and other information associated with this data frame. And we can look at the structure of each type of variable in the data frame. What we're going to do here is just take the column wind speed, the variable wind speed, and copy it into a variable called wind speed, which is an integer vector. Now, when I go to create a histogram on this integer vector, unfortunately it doesn't seem to work, and that's because there's one or more outliers. And if I run the R summary function, I can see the minimum wind speed is 0, the first quartile is 5.7, the median is 9.2, and the maximum is 1,048 miles per hour, which is a bit much. So here we'll just remove all the wind speeds that are over 1,000. And now when I run the summary, I see the max wind speed is much more reasonable and gusty, 40 miles an hour. And when I go and I create my histogram now, I can see the frequencies and the wind speeds that are much more in line with what we would expect. And I can give it an argument and get the probability distribution of the various wind speeds instead. And then I can next try and calculate the mean of the wind speed. Unfortunately, I get an NA, and this is because some of the data has missing data marked with an NA, and many of the R statistical functions, including mean and standard deviation, will return NA if there are any NAs in the data set, unless you tell it to ignore the NA values, which I do here by giving the option argument NA.rm, NA.remove is true. And now it comes back with a wind speed of 9.2. I can do the same thing with standard deviation. I need to go NA.remove, and I have a 5.3 standard deviation. So I run my histogram, and I overlay my wind speed. I overlay my probability distribution function with the mean and the standard deviation of the wind speed on top of it. And we can see that the normal curve has a mean of 9.2, and the spread of the curve corresponds to the standard deviation of about 5.3.